Hash set. Yet another weird looking idea that turns out to be quite useful in order to realize the idea of mathematical sets, where you can basically only test for membership, whether the collection has the element or not. Okay, so here is a simple example. Okay, so that's a hash set, and that can basically understood as a hash map. That's why the curly braces, but we don't give key value pairs, and please note that I have 3 elements. So this is not a hash map. What's the idea? Well, the keys, they map to themselves. So instead of key value pairs, which is a hash map, we have key pairs. Well, okay, we don't have them, but conceptually that's the idea. And so what's the purpose of that? Well, let's define this as let's call them numbers. Okay, and well, I can use it as a function. So numbers of 1, that's 1. So it's like, well, it's work like a hashback. I give a key, and what's the stored value? Well, it's the key itself. 2, 3, how about 4? Okay, it gives nil. Well, yeah, that key is not in that hash set. You can do this trick when you do the lookup. You can give a default value. Well, I just call it the keyword default, and when it's not there, well, you get some value back. That's a trick that might be useful later. Of course, not just this, get will work as well. So if you like the more traditional like function argument style, give a default, but I get 3, of course. But if I get something which is not there, well, I get that default value. If I don't give that, then I get nil. Okay, so what's the idea here? Well, it's you know, nil is falsy, and everything else is truthy. So therefore, this can be used for just checking membership in a set. So you use the hash set not because you want to store some value based on a key. It's just you want to ask the question, so, oh, do we have this key at all? So that's exactly what mathematical set is. It's just for it's a data structure that can test membership. So here I define 2 hash sets. It's fruit. Well, okay, I represent fruits with keywords. Okay, and it's a keyword is a very convenient thing to use when you just want to represent some sort of information. Okay, so these are defined. This is the set of fruits, and I have vegetables. Oh, maybe the tomato is a fruit as well. Okay, well, that's something to check later. But anyway, I have a basket, which is just a vector of these food items. And now comes the interesting thing. I can say that I want to filter vegetables from the basket. Oops. Okay, and this works fine. So it's like I could use the hash set vegetables as a function, because, well, okay, what does it do as a data structure? Well, a data structure as a function, and it's just, it does the lookup. If you know, carrot is there, it returns carrot, which is a truthy value. Therefore, using it as a predicate function, it will give logical true, and filter will take that element. Okay, so this is where it gets it's rather useful. You just have a set, you define a set, and you can filter with it, or you can, you know, remove as well. Well, I guess we will get the same thing if I remove fruit from the basket. Oh, sure, yeah. And here we have the fruit as well. Okay, so that's why we have this relatively strange data structure. This keys map to keys, or it's like, at least you can understand that way, but it's basically just a set. So now, of course, there is a bit of a problem here, because curly braces, so that would be exactly the mathematical notation for sets. However, hash maps are more fundamental in programming, so we have the curly braces for that. And for the mathematical set, well, we have the hash mark and the curly brace. So it's a bit the other way around, but as we saw that we use hash maps for representing composite data, or it's basically representing objects and database items, so it's used more often, hence the decision to represent hash sets differently. Well, okay, that's my explanation, but I think that's fairly straightforward to guess. So to summarize, in order to realize the idea of a mathematical set, which is just a data structure that can do membership testing, so the only thing it can answer whether an element is in the collection or not, and that's the only purpose. Of course, it's very useful in many situations. And one thing which okay, it didn't appear so far, but sets, they don't make any promise about keeping the order. Unlike vectors, where, you know, they have a specific order, sets, they can just change the order, because they don't promise to do that. It's not a sequential collection in that sense.